Next we have multiplying and dividing functions. So we're still referencing f and h for these examples. But what we'd like to do here is multiply the two together. So if I take my function for f, which is x squared minus 8x, and I'd like to multiply it by h, I'm going to use parentheses for this, 3x minus 1. And what we'll do here is we'll use the distributive property. We'll distribute this x squared to both terms here. So we'll end up with 3x cubed minus x squared. And then we'll distribute our negative 8x to both terms as well. So negative 8 times 3 is negative 24 x squared. And negative 8 times negative 1 is positive 8x. Finally, I combine the like terms that I have and simplify. So 3x cubed minus 25x squared, because these are the only two like terms. And finally, plus 8x, and I'm finished. Dividing two functions is a little bit more difficult, or could be at least. In this particular case, we have f of x, which is x squared minus 8x, divided by h of x, which is 3x minus 1. And what you'd like to do when dividing two functions is, if possible, factor them to see if we have any terms that cancel out. So on top, I can factor an x out, which would leave me with an x minus 8. And then the 3x minus 1 is still on the bottom. And when I look at this, I have no entire groupings or terms that are the same. So therefore, nothing cancels. So the actual fraction that I had before is the best answer. Now, the other piece when you have division with variables in the denominator is you have to restrict your x value. So in this particular case, x cannot equal any number that would make this denominator 0, which in this case is 1/3. So x could not equal 1/3. You'd have to include that piece to be 100% correct. And that's function operations, multiply and divide.